Hello everyone, in this tutorial we will be discussing how to perform image processing using AWS. In AWS we are using different services and different open source softwares available in the market to perform image processing using AWS. So the different services we'll be using are AWS S3, AWS Lambda and REST API. So the other open source software we'll be using is OpenCV. So we will be using these technologies to build a system that can perform image processing tasks on an image that you want to resize, analyze or apply filters on according to your preferences, and then make the processed images available via REST API. So introduction. So image processing is a crucial part of modern technology and AWS has revolutionized how it can be done. In this presentation, we will explore the many ways AWS can use to image processing, including image recognition, analysis, and transformation. Using AWS services, we can perform image recognition. AWS provides a wide range of tools to help with image recognition, including recognition and deep lens. These tools use machine learning to analyze images and identify objects, faces, text, and make it easier to organize and search through the large collection of images and datasets. Image analysis. The AWS services we will be providing some Lambda functions, or we will be using Amazon SageMaker, Amazon Recognition. These are different services available in AWS which can be used for image analysis, which involves extraction information from images, and these things include identifying patterns, detecting changes over time, measuring distances. So these services make perform complex image analysis tasks. So image transformation, like I said, there are various services which are available in AWS, like Amazon Elastic Transcoder and AWS Lambda, to perform image transformations in real time as part of a larger applications. So yeah, so I'll be showing in this tutorial we will be performing how to process image, like we'll be applying filters on an image for our respective image. So let's get started. So first, the first thing which you require for doing this tutorial is an AWS account. So first create an AWS account, and first create an AWS account, then we'll be proceeding with the rest of the tutorial. So in this tutorial, first we will be accessing AWS Lambda first. So here in this Lambda, we will be creating a function that will process the images. So in the AWS console, navigate to AWS Lambda. You can go from here, like you can type Lambda. Yeah, you see here AWS Lambda. Here you can be accessing AWS Lambda. So we will be accessing AWS Lambda, and then we will be clicking on create, go to functions, and then create a function. So using this, we will be starting author from scratch. So here in the function name, we will be giving a desired function name and runtime. Guys, be careful. Whatever runtime you are choosing, you just remember the runtime. Like don't if you are having packages in your laptop for the current version of Python is Python 3.10.6 something. So but here Lambda is not giving us the facility of Python version 3.10. So maximum select version 3.8. It is the most stable version available. All right. So most stable version available, Python 3.8. Select version 3.8 and click on create function. I already have a function and I will not be creating another function. So here, author from scratch, desired function name, runtime. Guys, I'm repeating again, it is the most important part. So Python 3.8, and then click on create function. All right. After creating the function, we will be coding some program into this function. So as you can see here, this is the function I have written for processing the image. So first I will be encoding a image. For encoding an image, we are using base 64, and for processing an image we are using CV2. You can see the imported packages here. Okay, I'm going to give a brief explanation about what OpenCV is. Alright, OpenCV is a popular open source computer vision library that can be used for image processing tasks. It provides a wide range of functions for an image manipulation, including basic operations like cropping, resizing, as well more advanced tasks like feature detection, object recognition, segmentation, and filters. Image processing using OpenCV typically involves loading an image from a disk, performing some operations on it, such as filtering, edge detection, color conversion, and then saving the results back to the disk. OpenCV provides a rich set of functions for these tasks, which can be used in a wide range of applications. One of the key advantages of using OpenCV for an image processing is its performance. The library is highly optimized for use for modern CPUs and GPUs and can take advantage of multi-core processing to speed up computationally intensive tasks. Additionally, OpenCV supports a wide range of images and video formats, making it a versatile tool for working with different types of media. Overall, OpenCV is a powerful and widely used library for an image processing that provides a wide range of tools and functioning for working with digital images. It is particularly well suited for application in computer vision, machine learning, and robotics, where image processing is a key component for many algorithms and systems. Okay, guys. So we will be first we will be typing a function. We will be first encoding an image, then we will be decoding an image, then lambda handler. Here in this lambda handler, we will be writing our main code. As you can see, we'll first decode the image. First we'll be encoding the image, then we'll be decoding the image. Then you can see image convert gray, BG gray. We'll be like applying a filter where we can convert a normal image to a gray image. All right. So gray image encode here. And here we will be returning status code 200. Status code 200 represents success, so we will not be changing that. And here in the body section we will be giving image gray, and we will be setting is base encoded true. All right, here it is our lambda function. Okay, so in order to run this, first we need to import these two, import CV2 and import base64. Like you guys can wonder that what happens if CV2 is not included in our runtime Python libraries. Yeah, see, CV2 is not included in runtime, and base64 is also not included in the runtime. So what are we going to do is we will be creating a bucket, an S3 bucket. So I'll be showing you here this an S3 bucket is like a storage for your files. Okay. So here in this S3 bucket, I have various buckets. So I'm sorry about that. So in this bucket, there is a bucket called Python. We will be Okay, I'll be showing you how to do that. We'll be first creating a bucket. See, as you can see here, bucket name. We'll keep everything as default only. We will not be changing anything. We'll be just be creating a bucket. Give your bucket a unique name. These names are these names can't be duplicated. All right, globally give a different unique name, like adding date to it or something or the other. So create a bucket. After creating a bucket, just go into the bucket and then click on upload here. So I'll be giving you the Python 3.8 package zip folder in the description box. You can access that in the description. So why am I providing Python 3.8 packages is because we are all the installed libraries like NumPy, Pandas, everything is there in that package folder. So you will be needing that folder for importing the packages in the Lambda function. Alright, so this Python package zip contains every single library you want to use in Python 3.8 runtime. Alright, we'll be uploading it, like you can upload it from here. See, you can add files, and see, I'll show you in downloads. See, Python package. I'll be posting this Python package in the description box, don't worry. So this Python package, you can download it, you can open it. Select the Python package and open it, and then you can upload it into the S3 bucket. All right, yeah, and I'm leaving it because I already have the zip folder in it, so I'm leaving it like this. Okay, so once you upload the zip folder into the file, into the S3 bucket, let it give it some time. After that, go into layers, go into lambda function again, select layers in the side navigation part. Here we will be creating a layer for the Python libraries. Like for the created function, we will be just creating a layer for it where it contains all the libraries in the version 3.8. We'll be creating a layer, like give a layer, your name, description, all the others. See, upload a zip file, upload a file from S3. See here, yeah, it's clear here. For files larger than 10 MB, consider uploading using Amazon S3. See, all our libraries contains 62.3 MB, so we can't directly import it in the layers. So what we are doing is we are importing it from S3. Yeah, see, you can upload files from S3. Okay, this S3 link I'll show you. Go to your S3 bucket, click on the python package.zip. See, you can see here object URL. This URL will be your object URL, which should be used in the layers. So copy this URL, go to layers, paste your URL here. Alright, and here this is the most important thing, Python 3.8 runtime. Alright guys, Python 3.8. Here you will be selecting Python 3.8, and we have imported successfully the packages. Click on create layer. Okay, this error is I think for the name thing, and you guys give a name and create a layer. Alright, then come back to your what do you say, lambda function. Click on add layer here, layers, add layer, and you will be redirected here and add a layer. AWS layers, select custom layers, and here you will be seeing your layer which you have just created. Select it. You will be having a particular version of it. Select the version and click on add. After adding this, you have successfully imported all the packages to your Python function. Alright, you can see, for that you need to configure a test event, create the test event, and give the body, and then click on deploy. After deploying it, click on test. After doing this, you will be getting no errors, like you will be getting status code 200. Yes, we have successfully completed the function which is required for conversion of image from normal to grayscale. Alright, now we will be creating an API for using it locally in our system to convert images. I'll not be saying convert images. You can write this lambda function however you want. Like you can see, I have here given a BG2 day, so you can do you can explore OpenCV2 and go to more image processing. Like you can do cropping the image, resizing the image. Like there are so many functions available in OpenCV2. So in this API gateway, we will be creating an API. Go to REST API, not private. Go to REST API. Click on build. Alright, after building, I have already created, so I'll not be doing it. Click on build. So I'll just show you how it goes. Okay, select REST new API, give your API a name, and then create an API. Alright, don't do anything from it. REST new API, give an API your name. Alright, from there you'll be seeing your created API here. Give it some time and it will be available. Here it's the see, from here you need to give some concentrate here. Create a method first. In that method, see, select post. See, already post I have already created, so it's not showing here. Create a method post and then select it. Alright, here you need to do nothing. While creating a method, you will be asked if you want to import any function from anywhere else. Select lambda there. Alright, select lambda there and select the existing lambda function which you have created for image processing. Alright, then come get into it and click on test. Here you can see, after clicking on test, internal server error. Just give me a second. Stages. Yeah, I have not deployed it. Sorry guys. Just give me a second. See, here it is a stage, like here it is your public link for your API. All right. Here this link can be used for your API calling in locally in your system. Here in the request body, you need to give the decoded images, like the decoded, uh, the decoded text. I'll be showing you. Just give me a second, guys. I'm really sorry for it. Just give me a second. Yeah. Just we'll be keeping this aside. Yeah. See, we'll be first uploading an image. See, this is the encoded string. This is the encoded string, guys, which we need to like give to the image processing. This one. I'll be pasting it here and click on test. Status code 200. See guys, as you can see, it is showing status code 200. It is running successfully. This is the decoded images string. See how long it is, guys. I'll just be selecting it, like I'll ensure that everything is selected. Just a second. Yeah, everything is selected. I'll be copying it and I'll be showing it to you here. I'll be pasting my link here. See my image. Yeah, see, I have uploaded an image normally, a color image, and it has been converted to grayscale. Our API is working successfully, guys. We have completed 70% of the work. Okay. Now our API is working, all our libraries and function is working well. We need to write a code locally so that, and we need to import the API and make it work. I'll be showing the code to you guys. So this is the code to convert into gray API for a given image. See, in the main method, I have given the image path and I am doing image. See, I'm reading the image path and I'm calling the function convert to gray API and I'm writing the file to the same folder again. Okay. See, in this function convert to gray API, I am using the API endpoint which we have just copied here. See, the API endpoint is available in your stages, guys. Go to stages. Sorry, no internet. Oh shit. Give me a second, guys. Yeah, we are back. So yeah, in the stages, you need to create a stage and then you have a stage here. Invoke URL. This is your API link, guys. This is the API link which you need to copy and paste it there. Yes, this is the link. You have pasted it here and you are searching for post requests, and then we are opening the image, and in the API is doing the conversion for us. Like the API is calling the lambda function, the lambda function is executing the image processing, image convert, like the filtering thing. The function is getting executed and it is giving the output to the API itself, and we are fetching the API and we are calling the API here for our image. See guys, this is the test image. It is filled with lot of colors here, as you can see. Now I'll be clicking on a run function for the main.py. Run Python file. If the Python file is running, yeah, the Python file has successfully run. And as you can see, there is another file which has just appeared here. That's it guys. The image has successfully changed its color from colors to gray, and yeah, that's all for the image processing tutorial today. So see, so by using AWS for image processing has many benefits. It's like you don't have you just have to write your function for the OpenCV. Using OpenCV, you just have to write the function code for the processing of your image. You can call the API, and you have many benefits like scalability, reliability, cost effectiveness. AWS allows you to easily scale your image processing capabilities up or down as you need it, and provides a range of tools to ensure your images are processed quickly and accurately. So in conclusion, AWS revolutionized how image processing is done, providing an easy to use, cost effective platform for a wide range of image processing tasks. Whether you need to identify objects in the images, analyze patterns over time, or transform the images to achieve desired results, AWS has the tool that can help for you. And thank you guys. I am Shanmuga Satvik, and thank you for watching my video.